Have you ever wondered how we can actually use math to describe things happening in the real world? Well, today, we're going to dive into a super powerful tool for doing just that, linear equations in two variables. We'll break down what they are, how to solve them, and why they're such a big deal in math and science. So let's get started.
You know, this quote from Edmund Halley absolutely nails it. Algebra isn't just a bunch of random rules. It's really a language, a way to take a messy, real-world puzzle and turn it into a clean, simple equation that we can actually solve.
Okay, think about this super simple scenario. In a cricket match, two batsmen scored 176 runs together. The thing is, we don't know what each one scored individually. That means we have two unknowns. So let's call the first score x and the second score y. How do we write that as a math problem? It's easy. X plus y equals 176, and boom, just like that, you've created a linear equation in two variables.
So here's our game plan for this explainer. We're going to start with the basics, what these things even are. Then we'll get into the wild fact about their solutions. After that, we'll see how to actually draw them, look at a couple of special cases, and then wrap up with some really important tips on what not to do.
All right, first things first. Let's build our foundation. What exactly are we talking about when we say linear equation in two variables?
Okay, this is the official blueprint. ax plus by plus c equals 0. So x and y, those are our two variables, and a and b, those are just the numbers attached to them. We call them coefficients. C is the constant, just a plain old number by itself. Now, the only big rule here is that a and b can't both be 0. Why? Because if they were, our variables would totally disappear.
Let's see this in action. Say we've got 2x plus 3y equals 4.37. To get it into that standard form, all we have to do is make one side of the equation equal 0. So we just subtract 4.37 from both sides. That gives us 2x plus 3y minus 4.37 equals 0. And now it's super easy to see what's what. A is 2, b is 3, and c is negative 4.37. It's really just about rearranging the pieces.
All right, now for what I think is one of the coolest parts about these equations. Unlike the ones you're probably used to with just one variable, these have a totally different kind of answer.
Now, this is a huge change, right? When you have one variable, like in 2x plus 5 equals 0, you get one and only one answer. But with two variables, like our cricket problem, well, the possibilities just explode. Could the scores be 176? Yep. What about 50 and 126? For sure. It's like we've gone from a single specific answer to a whole river of infinite solutions.
So, if there are infinite solutions, how in the world do we find any of them? Well, the trick is actually pretty simple. You just pick a value for one of the variables and then figure out what the other one has to be. Let's try it with x plus 2y equals 6. Honestly, the easiest place to start is just to set one variable to 0. Let's make x equals 0. The equation becomes 2y equals 6, which means y has to be 3. So our first solution pair is 0, 3. Now let's flip it and set y equals 0. The equation now says x equals 6, so our second solution is 6, 0. And remember, the x value always comes first in the pair. And we don't have to stop there. You could plug in literally any number for x and find its matching y. If x is 2, then y is 2. If x is 4, y is 1. You can see from this table how all these different pairs of numbers work for the exact same equation. Okay, so we've found solutions using algebra. Now let's see what happens when we try to visualize them. This is where it all really starts to click. Yeah, it's not a coincidence. The line in linear is a massive clue. The geometry behind all this algebra is actually beautiful.
So here's the magic. Every single solution pair we found, like 0, 3 or 6, 0, isn't just a pair of numbers. It's a coordinate for a point on a graph. And when you start plotting these points, something amazing happens. They don't just land all over the place, they all fall onto one single perfectly straight line. That line is the equation, just in picture form.
So how do you actually draw one of these? It's a super simple three-step process. First, find at least two solution points. Second, plot those points on your graph. And third, grab a ruler, connect them with a straight line, and make sure to extend it out. And hey, here's a pro tip for exams. Always find a third point. If that third point also lands on your line, you can be pretty much 100% sure you got it right.
Okay, we've got the basics down. Now let's look at a couple of special cases that can look a little weird at first. Like, what happens if it looks like one of the variables is just missing?
So take an equation like x equals -4. It looks weird, right? But you can think of it as x plus 0y equals -4. What that really means is, no matter what value you pick for y, x is always going to be -4. So you get points like -4, 0, -4, 3, -4, 5. And when you plot those, you'll see they make a perfectly vertical line. The same logic works for something like y equals 3. In that case, y is always 3, no matter what x is, and that gives you a perfectly horizontal line.
All right, we've gone through all the theory. Now it's time for some real-world practical advice. Let's look at the common traps people fall into so you can avoid them, especially when it counts, like on a test.
So there are a few classic mistakes that are really easy to make. Little errors with negative signs, messing up fractions, stuff like that. But honestly, the single biggest mistake, the one that trips up more people than anything else, is forgetting the golden rule of algebra, keeping your equation balanced. Let's zoom in on that one.
The golden rule is so simple. Whatever you do to one side of the equal sign, you have to do the exact same thing to the other side. So for 2x plus 1 equals 5, to get x by itself, you need to subtract 1. But you can't just subtract it from the left. You have to subtract it from both sides to keep the whole thing true. It sounds basic, I know. But forgetting this is the #1 cause of wrong answers.
Okay, so here's your final checklist. 1. Always double-check your negative signs. 2. Always keep the equation balanced. And 3. This is a fantastic habit. Once you find a solution, plug it back into the original equation. If it works, you know for sure you nailed it. It's the ultimate self-checking trick.
So, to recap everything we went over, a linear equation in two variables follows that standard form ax plus by plus c equals 0. It has an infinite number of solutions, each one a little x comma y pair. When you graph all those solutions, you get a perfect straight line. And finally, those special cases, x equals a or y equals a, give you those perfectly vertical or horizontal lines.
So let me leave you with this final thought. Think about it. You can draw an infinite number of lines through one single point. But what happens when you have two separate points? Well, there's only one possible straight line that can pass through both of them. And that really simple idea from geometry is exactly why we only need to find two solution points to draw the entire infinite line of an equation. I hope this explainer helped connect some of those dots for you. Thanks for watching.